We are back with the second half of the experimental design video. If you were watching this first, you are halfway through, so you should go back and watch the experimental design number 1 video first. In that video, we talked a lot about independent and dependent variables, experimental control groups, operationalizing hypotheses, fun stuff. So this video, we're going to focus on some more aspects of experimental design that are important for us to know. And so we should just jump right off. So if you remember the standard or the sample hypothesis that we were going off of, which is that if you give cookies before class, if you eat a cookie before class every day, you'll have eventually higher averages on your test scores. So let's, we were running off of this data that the experimental group, which is the group that receives the independent variable, right, the cause variable, in this case got a 95% on their test scores, right, which is the dependent variable or the effect. The cookie causes the effect in the scores. And the control group got an 82. And we can sit here and say, wow, that's a really big difference. Of course, this is important. But what if instead of an 82, it was an 85? Okay, still pretty sure that that's a pretty big difference, right? That's important difference. That's 10 points, 10 percentage points is a lot. But what if it wasn't an 85? What if it was a 93, right? 93, 95, that's not as big of a difference as obviously some of the other numbers, and maybe not a big of a difference that we might say is important. So there's another type of thing that we need to be able to understand. And that is something that is called in psychology statistical significance. Okay, statistical significance is something that if you're in stats, you're going to have to probably figure out how to calculate. For psych, you don't. You just need to know what it means. It's just like correlation coefficients. You need to know what it is, but you don't need to know how to calculate it. Statistical significance is shown by a p-value. And it is usually expressed in an equation. And a p-value is, and the definition of statistical significance is the likelihood that the result is caused by chance. Okay, so let's say that we were running that cookie experiment, and we went through the process, and we got that 95 to a 93 result. What's the likelihood that the difference in the two, right, the difference of the 95 to the 93 is caused by chance? Because no matter what we do, there's still a likelihood that it's caused by chance, right? We're not talking about chemistry here, where you know what's going to happen if you can combine two chemicals with the same mass and blah, 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 right? We're talking about human beings, human behavior is complex, and there's always an element of chance involved. So you need to be able to figure out there's a mathematical formula. Again, we do not need to know what it is, that can explain whether or not the result was caused by chance. Okay, this is important for us to understand. It doesn't matter how close the results were. All that matters is whether or not the statistical significance is occurred, right? Is there a statistical significance of the data? So in other words, just because the one group got a 95 and the other group got an 82, that does not necessarily mean that the cookie caused the difference. If those results are not statistically significant, then we have to say that it could have been done by chance, even though those numbers look really good and they're nice and flashy. For social science, in order for something to be considered not caused by chance, or to be statistically significant, and if you want to read between the lines, I don't want to say valid, but that we can say that the independent variable caused the dependent variable. And remember, that's the goal of experimentation, right? Is to prove causation. So the value that it needs to be is no greater than 5%. So that means that you can have a 5% chance that the experiment that you just did is the result of just pure luck, that just complete random coincidence produced the results that you have. 5%. And according to social science, that's fine. That is totally acceptable, and we can say that the results were statistically significant and therefore, publishable or validating the research. And that usually shows up in something that's an equation. P is less than or equal to 0.05, right? So again, it doesn't matter how big the difference is in between the control group and the experimental group. All that matters is the finding statistically significant, right? Even that 93 to 95, right? If it's statistically significant, then that means that eating a cookie can give you, with as certainty as we can expect to have in a social science, that cookie caused that extra 2% of the average. Okay, statistical significance is super important, and it's one of those things that guys always struggle with, right? It has to do with, is the result caused by chance or not? It is something that almost always comes up on the FRQs, and it will definitely show up on tests. So both in the tests, the unit tests, and then the tests, the AP exam, multiple choice section. Okay. Let's talk about the other part of science, and this goes into the humility aspect that I've stressed in class, and that's replication. In order for a scientific study to be considered accepted, it needs to be replicated. In other words, other scientists need to do the same experiment, following the same parameters and experimental procedure, and they should be able to get the same results. This is like a check to make sure that there's not any bad science going on. If it's a non-replicated result, we call that a preliminary finding, right? And you'll hear that in the news sometimes, like, oh, preliminary results from this study say that drinking coffee is bad for you. Okay, all that means is that someone did an experiment or some other type of study, and the results have not been replicated yet, right? The replication is important. In science, in social science, it's called peer review, right? Other scientists go out, they try to do the experiment. If it all works out, we're good. Now, where does this show up, right? It's kind of an interesting thing because I think it's something we've all heard. So in 1970, there was a famous study conducted by Linus Pauling that studied whether or not vitamin C prevented colds. Okay, so let's go back to our old standby and think about what the independent and dependent variables are. Okay, so in the experimental group, right, that is the group that receives the independent variable. That means that they got, a dose of vitamin C. For the control group, that means that they got a placebo, right, a sugar pill, a pill that has no medical properties in it at all. And the experimental group got 45% fewer colds over the course of the study than the control group did. Now, we're sitting here like, wow, 45%, that's really, really good. Like that's pretty remarkable. That has to be statistically significant. And it was. So the stats came back and that, yep, it's got a less than 5% chance that this result was caused by chance. The problem is despite this study being, over like 10,000 people and went over the course of 2 years, it's never been replicated. No matter how many times it's tried, and it's been tried to be replicated at least 19 times that I'm aware of, it never holds up. It always just washes out. There's no difference between the experimental group and the control group. But yet, we all think that vitamin C prevents colds, right? There's Emergen-C, which is the thing you take to go on an airborne, right? All that is just a vitamin C tablet. Why do we still think that, right? Why do we still think that vitamin C prevents colds? Maybe even your parents will say like, oh, you're starting to get sick, drink this orange juice, right? There is no real scientific basis to that we can find in doing this research. It goes to show you the importance and the value. I want to say value, the importance that is placed on findings, right? Especially findings that make big shock waves. Think about all of this, psychologists say that this happened, right? Or go back to the thing I said before, that coffee is bad for you, right? And then like 2 weeks later, there's another study that say coffee is good for you. None of these things are being replicated, right? They're just being studied, and there's a small sample size, and there's no replication here. So we have to take a lot of this stuff with a grain of salt, just understanding that these are preliminary findings, and until they're replicated, they can be sorted out. Now, the interesting thing with psychology, I think, is right now as we speak, psychology is kind of going through a replication crisis. There's a movement within psychology to go back and redo all of these famous experiments that made big, splashes and changed culture and raised awareness, but actually turns out that they're not being replicated. And remember, if they're not replicated, then that we can't really hold them as valid. So the famous example is, maybe you've heard of this. It's called power posing. It says that before like a stressful event or something like that, that you should stand, like Superman with your arms on your hips and your chest stick out, or that you put your feet up on the desk and put your arms, behind your head like a CEO, right? That the idea is that if you put yourself into these positions, it makes you feel, ready to go. And it kind of gives you, just by kind of phoning in the motions, it gives you that energy or that thing that you need to put you over the edge. It made huge waves. There was a TED talk where the person who did this study talked about the importance of that at job interviews and all these other things. It's not replicated. No one's replicated that study. And they've tried and they keep not getting any results. So we have a whole bunch of things in psychology where there's a big study, it makes a big, important statement, it changes the way we think about things, and then no one ever decides to replicate. And the issue here really gets at the fundamentals of the kind of business of psychology, right? Imagine you're a psychology professor doing research in a lab at, whatever university. What's going to get you recognition? What's going to get you clout, right? What's going to get you a research grant that's going to provide you more money to do the work that you want to do? What's going to get you, international recognition? It's making a big splash and coming up with a new finding. It's not, oh man, this guy's really good at replicating all these other studies. That is not something that people will publish. That is not something that people will read. That is not something that universities tend to want to fund, right? So there's this huge replication crisis going on right now in psychology as a field, because there's just no one's out there doing that work. So there's a movement now of people going through and finding these studies and replicating them so that we can really try to understand, was this just a fluke? Was this just like the vitamin C preventing colds, or is this reality? Okay, so here are a bunch of terms from experimental design that we've talked about so far. They should all be familiar to you. If you have questions about them, let me know. Look them up in the book to make sure that you fully understand them. But I think it's important for us to just kind of throw all of the terms here on one slide. I'm just going to kind of move quickly through this so that we can kind of, just, it's important. It's a lot of stuff I've already said. We know that experimentation searches for cause and effect relationships, right? This is more than correlation. This is actual causation. And that's why we need to make sure that we're reducing the confounding variables, and we are making sure that our results are statistically significant and that they're replicated, because these are the kind of big three things that we need to do. We need to make sure that we focus on what behaviors we want to change, right? Sometimes we think we're trying to change one behavior, but we have unintended consequences. So being extremely clear about the procedures that we're following in experimentation is important. We know that we need to have blind and double-blind experiments, right? That a blind experiment means that one of either the participant or the experimenter doesn't know what group they're in, right? They are blind to that knowledge. Double blind means neither the person in the experiment or running the experiment knows what group they're in. Someone else is in charge of that, and the person who's running the experiment or administering the drug or whatever doesn't know what drug it is, doesn't know who this person is, just in and out, right? As cold and scientific as possible, I guess. But it's a way to ensure that, there's no skewing of the data. There's no experimental bias that can creep in. And finally, placebo effect. So one of the things that we've studied that we notice is that if you just bring people in and say, all right, we're going to test a new medicine for, let's say, migraines, and, half of the people get a sugar pill, right? A placebo, a fake pill with no medicine in it at all. Some some people will report that their migraines were getting better, and that they are. And that's called the placebo effect. That because people think that they're getting medicine, that their body responds as if they got medicine, even though they received no medicine. An example that's a little bit closer to home. If you ever had a headache, like I had a headache earlier today, I took some Advil, my headache went away within like minutes. I'll say 5 minutes, 10 minutes, my headache went away. That's actually the placebo effect, because ibuprofen or Tylenol or whatever you're taking takes 30, 45 minutes to get into your bloodstream and work its way through, and that's when it starts to alleviate pain, not 5 or 10 minutes. So every time you take a pill for a headache or knee pain or back pain or whatever you guys are struggling with, and your pain goes away pretty quickly, that's actually the placebo effect starting that. The medicine kicks in, but not until later. So that's kind of an interesting way to keep in mind with the placebo effect. And it has, we don't know why it works. We have absolutely no idea how the placebo effect actually works. We just know that it does have an effect on the data. So you'd expect, if it's the migraine medicine, that, 30% of the people who took this medicine reported no migraines, and that all the people who had a placebo, no change. But instead, you have like 8% of the people who got a placebo said that there was going to be change, that their migraines started getting better. So it's not everybody. So we can't only rely on placebos, right? Because that's usually a question that people have, like, well, if that's the case, why don't we just make everything sugar pills and it works? Well, it's because it doesn't work for everybody. It doesn't work all the time. And medicine is certainly better than no medicine. Okay, so we know that the independent variable is the experimental factor. It's a thing that we are changing to see if it produces a result. The difference in the result is the dependent variable, right? That is how we measure that. Remember, everything has to be measured here. And again, the goal with experiments is to manipulate an independent variable while keeping everything else as similar as possible, because any change in the results will likely be because of the change in the independent variable. As silly as it might be, as small as it might be, that is how it works. And so keep that all in mind as you continue to learn more about experimentation. We will come back with another video. Yeah, there's a lot of videos here. We'll come back with another one all about statistical reasoning and how we can learn to apply math in our psychology studies. All right, guys, until then, see you later.